Hello students, welcome to Sri Jayendra's Ring Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 2 of a unit waves. So let's begin with today's class. In today's class we are going to discuss about the traveling wave. So let's begin with traveling wave. First, let's learn the general equation of traveling wave. The general equation of traveling wave could be given as it's a function of ax plus or minus of bt, or this could be represented as function of a into bracket x plus minus b by a into t. Here this terms that we call as a b by a, this represents v of wave. It says the wave velocity is b by a, and this plus minus represents that it is just x plus minus vt. So if it is x plus vt, a wave is traveling in negative x direction, and if it is x minus vt, then it represents that wave is traveling in positive x direction. Yes, I hope this is clear. So let's begin with the questions based on this. Let's suppose we are having the question that y is equals to x minus of 4t. Find out first direction of propagation. And second wave velocity. So my given relation is y is equals to x minus 4 into t, and this standard relation what we are having is y is equals to x minus of vt. Yes, so the wave velocity is equals to 4 meter per second, and as these two are connected with the negative sign, that means a wave travels in positive x direction. This is the direction of propagation of a wave. This is y is equals to x minus 4t, and from this it's a y is equals to x minus vt. I hope this is clear. Did you done the same thing? Have you? Great. Let's look at the second question. Let's suppose I have been given that y is equals to 4x plus 3t to the power 3, and they said again find out wave velocity and direction of propagation of wave. So how will you do this? So first I need to rearrange this, because this isn't look alike my standard relation. So if I rearrange this, it's a 4 cube as a common, it's an x plus minus, or here it's a plus, so let's write down the plus only, x plus 3 by 4t to the power cube. Yes, so now I can relate this with the function of, it's an a x plus b by a into t to the power n. Yes, and this is the velocity, or so velocity of a wave, it's a 3 by 4. It doesn't have any relation with this cube. I hope you understand this. This is not having any relation with the power that A is having to it. It's a v which is equals to, it's a velocity of wave which is equals to 3 by 4 meter per second. I hope this is clear. Is it clear? Is it great? And as this relation y is equals to 4 cube into bracket x plus 3 by 4 t whole cube, so this wave travels in in negative x direction. I hope this is clear. Does it? Do you have any doubts? Is there anything? No? Great. Ready for the next question? Let's have a look. The question says y is equals to 10 divided by, it's an x square plus 60 plus 9 plus 10. Find out. Find out wave velocity and direction of propagation of wave. Assume that this function represents traveling wave. What should be done? What should be done? So what I supposed to do is, it's a y which is equals to 10 divided by, this is x square plus 60 plus 9, so this is equals to x plus 3t whole square plus 10. And as you can see, this bracket represents the x plus vt kind of thing. So wave velocity would be equals to 3 meter per second, and it's a direction of propagation for this wave is negative x. I hope this is clear. Is it? Are you sure? So ready for this kind of question? Are you? Let's have one more question based on this concept. It says that y of x comma t is equals to 0.8 divided by 4x plus 5t whole square plus 5 represents a moving pulse where x and y are in meter and second respectively. Find first direction of propagation of wave, second wave speed, next it's a maximum displacement from the mean position. It's a maximum displacement from the mean position. So how will we do this? What is to be done? So the relation is, it is y is equals to zero point 0.8 divided by 4x plus 5t whole square plus 5. So first let's rearrange this according to our standard formula. It's a zero point 0.8 into bracket 4 square into bracket, this is equals to x plus 5 by 4 into t whole square plus 5. Yes, so v, which is equals to 5 by 4, which is equals to 1.25 meter per second. So this is the wave velocity. This is the wave velocity, which is equals to 5 by 4, which is 1.25 meter per second. I hope this is clear. Direction of wave propagation, direction of propagation of wave is negative x direction. I hope you are clear with this. Is it clear? Great. Now let's find out the third. It's a maximum displacement from the mean position. So this is the given relation, which is equals to 0.8 divided by 4x plus 5t whole square plus 5. So what we understand is y is maximum only when 4x plus 5t tends to 0 or it is 0. So this is equals to y is equals to 0.8 divided by 5. Even this can be considered as an amplitude. So this is equals to 8 by 10 into 5. It's 8 by 50 meter. This is the maximum displacement of the pulse from its mean position. I hope this is clear. Is it clear? Is it clear? Are you sure? Great. Now let's understand that uh, let's derive an equation that can check for me that whether this relations represents a traveling wave or not. So it's a differential equation. Differential equation of traveling wave, which gives me a condition as it's a del square y by del t square is equals to v square into bracket del square y by del x square. So this is a condition. This is a condition to check whether the following relation represents a traveling wave or not. Please note this. Please note this. Have you noted this? Yes, such as in the SHM, we have the condition which is equals to A is equals to minus of omega square x, or it's an A is equals to minus of, or I should say it's a minus of x. Yes, so this is the condition of SHM. This is the condition to check whether the following relations will represent a traveling wave or not. If any relation is there which is going to satisfy the above relation, then it can represent a traveling wave very easily. But if any relation is there which is not representing or which is not satisfying the above relation, is not going to represent the traveling wave. I hope this is clear. Have you noted it? Have you? Great. So now let's check one of the function, that whether this function can represent a traveling wave or not. So let's have a look. Suppose the function is that y is equals to x square plus v square t square. Check whether this function represents traveling wave or not? So we have the relation which is equals to y, which is x square plus v square t square, and let's suppose differentiate it first with respect to time. Then it's a del y by del t. This is, as you know, this is the partial differentiation, and when we are differentiating it partially with respect to time, x is constant for me, so it's a del by del t of x square plus v square t square. This is equals to, x is a constant and differentiation of any constant is 0, so this is 0 plus v square multiplied by, it's a d by dt of t square, which is equals to 2t, but this is just delta y by delta t. I need to differentiate it one more time, so it's a del square y by del t square. This is equals to del by del t of v square into 2t, so this is equals to 2 into v square. Okay, keep it aside as a relation number 1. Same way I am having this relation, which is y is equals to x square plus v square t square. Let's check del square y by del x square would be what. So let's first do del by del x of y, which is equals to x square plus v square t square, as v square t square is constant because now I am differentiating with respect to x. So del by del x, this will give me the 2x, again del square by del x square of this 2x, which will give me the 2. I hope this is clear. Is it? Great. So from this, it's a del square y by del t square, which is equals to v square into bracket del square y by del x square. Del square y by del t square, it's a 2 into v square, which is equals to v square into del square y by del x square, it's a 2. Yes, so this 2 are equal, so this function represents traveling wave. I hope you understand this. Do you understand this? So from this relation we can identify very easily that this function represents traveling wave. No, this function is not representing traveling wave. Yes, so you need to just rely on this condition, but for this you need to differentiate the function with respect to time partially twice, and then you need to differentiate partially function of y with respect to x twice, and then you need to compare it left hand side and right hand side. I hope this is clear. Is it clear? Is it? Now do you have any doubts? No? Great. Now let's learn one new aspect, one new topic, that is the relation between particle velocity and slope of wave shape. Let's suppose we have the simple harmonic progressive wave, which could be given as y is equals to a sine omega t minus of kx plus phi, and from this if I differentiate this with respect to time, it's a del y by del t. Then this is equals to del by del t of a sine omega t minus of kx plus phi. So this is equals to del by del t of a sine omega t minus kx plus phi. This is a omega cos omega t minus of kx plus phi. Please note this as a relation number 1. Now I am going to differentiate this. Same with respect to x. So if I perform del by del x of y, which is equals to del by del x of a sine omega t minus of kx plus phi, then this could be given as this is a sine, it's a cos omega t minus of kx plus phi. Again one more differentiation and it will give me a minus of k. So this is the relation. This would be the function 2. I hope this is clear. Now let's take a ratio of function 2 to the 1. So if I do this, it would be the relation 1 divided by relation 2. Then this will be, it's a del y by del t divided by del y by del x, and this is simply the a omega cos omega t minus of kx plus phi divide by minus of a into k into cos of omega t minus of kx plus phi. So if I cancel this is, then it's an a and a has gone, this cos function has gone. So I have been left with it's a delta y by del t divided by del y by del x. This is equals to minus of omega by k, and this del y by del t, this is equals to particle velocity. This is equals to minus of velocity of wave multiplied by del y by del x. This del y by del x is what we can say is the slope of the wave shape. So this is something like this. It's a particle velocity which is equals to minus of wave velocity multiplied by slope of wave shape. Please note this. This will play a very critical role to identify very general thing. Please note this. Have you noted this? Have you noted this? Yes. So let's be ready for questions. Let's suppose I have been given a certain wave, something like this, and it has said that a transverse wave is traveling along a string in the positive x-axis. Identify the points moving upward and downward. They have given the points as such as this is the B, this is the C, this is the D, this is the F, this is the G, this is the H. Yes, these are the points they are talking about. So how will we do this? So basically we have the relation that which says that particle velocity will be is equals to minus of wave velocity multiplied by dy by dx, or it is just the slope of the wave shape. So as they have mentioned that this wave is moving in the positive x direction, so it's a wave velocity is a positive one, so this term is the positive one, v wave, but it has been attached with the negative sign. So if dy by dx is negative, that means particle velocity is positive, And if particle velocity is positive, that means that particle is moving in the upward direction. And if dy by dx is positive, then this means a particle velocity is negative. I hope you understand this. So if dy by dx is positive in this case, then its a particle velocity will be the negative one. But if dy by dx, is negative in this case, then particle velocity will be the positive one. I hope this is clear. And if particle velocity is negative, that means particle is moving in downward direction. And if particle velocity is positive, that means that particle is moving in upward direction. I hope this is clear. Is it clear? Is it? Great. So let's now try to understand how the slope could be identified, as well as you can easily calculate the slope as well. That if I make a tangent over here, this is how we calculate the slope. This is the theta, and this theta is the acute angle. So at point B, slope is positive. This is, if you look at the C, yes, if you make a tangent over here, this is the obtuse angle. And if it is an obtuse, shall I redraw this? Shall I? Let's have a look. Expanded version, yes. This was B, this was C, this was D, this was E, this was F, this is G, and this is H. Yes. So at this point, this is slope. So slope at B is the positive. Slope at C, yes, it's a 0 because it's a straight line. Slope at D, as you can see, this is the tangent, and this will make an obtuse angle. So if it's an obtuse angle, it's an m of D, which is equals to 0. I hope this is clear. Is it clear? Yes. Again, same thing, m at E, again it's an obtuse. So m at D is negative, sorry. M at D is negative. M at E, again it's a negative. M at F, again it's a negative. M at G, it's a 0. And M at H, what it would be? M at H, yes. What it is? Yes, it is again negative. Yes. I hope this is clear. Is it? Sorry, this is positive. So from the relation I can identify that points D, E and F are moving in the upward direction. These are moving in the upward direction, and points B, H, points B and H are moving in downward direction. Have you got this? Have you? Great. Do you understand this? Any doubts up till now? Is there anything? Is there? No? Great. So let's wind up the session over here. This was about the traveling wave and one very important relation between the wave velocity, shape of the wave and traveling wave. So please understood this, that only the practice of this kind of questions can help us to do the questions. If we can do the practice, we can be saved. Yes, these are very important topics and they are having a very high probability to be asked in the examination. At least two questions from the waves is going to be asked. Either it could be a NEET examination or it would be a JEE examination. So please go through this very carefully. Thank you. Have a good day. Take care. Bye bye.